We have already looked at how to solve some basic radical type equations, but now we need to look at a new category, and those are radical equations that contain more than one radical. Now the steps that we outlined before are going to be the same. It's just that certain steps are going to have to be repeated. Now let's start with an example of where we have just one radical instead of more than one. Just to sort of go back over the steps that we've talked about before. Let's say we have the square root of x minus 5 minus 4 equaling a negative 1. Now, to get rid of this radical, the first thing we have to do is isolate it. So whatever radical you seek to get rid of has to be isolated first. So I will do that by adding 4 to both sides. These 4's cancel, and you get the square root of x minus 5 equaling 3. Now that the radical is isolated, it is a square root, so I can get rid of it simply by squaring both sides. Remember that squaring a square root means they just cancel each other. The x minus 5 comes out unchanged. 3 squared is 9. So now I can, since I have a linear type equation here, I can add 5 to both sides, and I got x equaling 14. Now remember, when you are solving an equation of this type, you really need to check your answer because extraneous solutions are very easy to come up with. So for example, with this one, I can plug back in and get that the square root of 14 minus 5 minus 4 is the square root of 9 minus 4, which is 3 minus 4, which is negative 1, so that solution checks out. Just because this was a negative value over here didn't automatically mean that we were going to get no solution. We have to check these. Now the main type of equation, though, that we want to look at right now is, like we say, one with more than one radical. So if we were to look at, say, square root of 3x minus 3 equaling the square root of a 4x minus 1, the first radical that I think I'll get rid of is this one on the left because it's already isolated, so that much is done for me. So I'm going to square both sides, and I strongly suggest, as a matter of fact I urge you, instead of just writing down a little square out here, rewrite this right hand side, or you will not multiply it out correctly. So you want to write it out twice so you can do something resembling the foiling technique. Square root and square will cancel. 3x minus 3 will come out. And again, the multiplication here is going to be a first times first. Square root times square root will cancel, and you'll just get out a 4x. Outer product will be a minus square root of 4x. Inner product will be another minus square root of 4x. And last times last will come out as a positive 1. Alright, combining like terms, I'm going to have a 4x. I've got the plus 1, and now I've got 2 of the square roots of 4x, well, negative 2 of them. And like we've said before, we have to isolate a radical to get rid of it. So I'll subtract 4x from both sides. Subtract a 1 from both sides. And I am ready to square both sides again. And as I did last time, I will square this by foiling. You have to be really careful with this foiling. First times first, negative times negative give you a positive x squared. Your outer product, negative negative, will give you a plus 4x. Inner product, another plus 4x. And last times last will give you a plus 16. Over here, the negative 2 squared will give you a 4. Square root will cancel square, and 4 times 4x. So I'm going to have an x squared plus 4 and 4 would be an 8x plus 16 equaling a 16x. Now, what we've got here is a quadratic. So I need to set things to 0. Got x squared minus 8x plus 16 equaling 0. Now with your quadratics, there's a number of ways to solve them. This one might be factorable, and that's the easiest if that will work. So we'll try. Let's see, for 16 I think we'll go with a 4 and a 4. A minus and a minus, and that gets it. And with a quadratic, I might have thought we were going to have two solutions, but as it turns out, we really only have one, if it actually works when you plug it back in. Plugging it back in, you're going to have the square root of 3 times 4 will be a 12 minus 3. Square root of 9, which is 3. Now that's the left-hand side. Remember, your original right-hand side was here. So we're going to have the square root of a 16 minus a 1, which is 4 minus 1, which is 3. Yep, we do have equality. So again, we have an answer that checks out. Now I think perhaps it would be a good idea to look at least one more of those, because the squaring both sides part can be a little bit tricky. Okay. Actually, I think I'll go back to this page and get a clean piece of paper that way. And let's try one more. Let's take the square root of a 3x plus 1 equaling the square root of a 2x with a plus 1 on the outside. Again, one with two radicals. I'm going to square both sides to get rid of the radical that's already isolated. Squaring the right-hand side really should be done by writing it out twice and foiling. Square root cancels square, 3x plus 1. And over here, first times first, square root cancels square root, you've got a 2x. Outer product is plus the square root of 2x. Inner product is plus the square root of 2x. Last times last is a plus 1. Gathering up any like terms, 2x plus 1 plus 2 square roots of 2x. Bringing things to the other side to isolate the root again. Subtracting the 1. And squaring both sides one more time. Gives me an x squared equals an 8x. Again, quadratic means set it equal to 0, factor, set each factor equal to 0, and we have a potential of two solutions. Of course, both have to be checked. Plugging in the 0 first, square root of 3 times 0 plus 1, square root of 1 is 1. And then plugging in the other 0, square root of 2 times 0 plus 1 is 0 plus 1, which is 1. So the 0 checks. Next one, square root of 3 times the 8 plus 1 is the square root of 24 plus 1, which is the square root of 25. And on the other side, square root of 2 times the 8 plus the 1 is the square root of 16 plus 1, which is 4 plus 1, and of course both of these turn out to be 5. So the 8 checks. So these things can be worked by hand by squaring twice. Of course, you always have to check. Now, we can also work these on the calculator. And actually working them may not be the easiest thing, but they can at least be checked on the calculator. We'll try and do both. I go for my y1 and I put in the original left-hand side, which is the square root of 3x plus 1. So second function, square root 3x plus 1, close the parentheses. Now for the right hand side, that goes in for my y2. So that was the square root of the 2x, close parentheses, so I can put the plus 1 on the outside. Now, if we graph these two equations, we'll see that the two graphs hit each other. And finding those intersections, we go tracing over and zoom in just a little bit. You see the two graphs, the first one being drawn, the second one being drawn, and they do in fact hit each other. And you can also look, another place to check answers is on a table. Looking at a table, we see x value of 0 gave matching y values. And scrolling down, so the x value of 8 gave matching y values. So we're basically confirming here on the graphing calculator that the solution is exactly what we thought it was. And again, if you're good enough at manipulating these graphs on the calculator, you could actually find those solutions graphically instead of algebraically.